RHS syllabus now is that we have to do a digital soil test and a conductivity test. So we're going to have a look at how you do a digital test on pH rather than using the old barium sulfate and universal indicator methods. And one of the reasons why people use a digital tester is that it's more accurate. You can calibrate it so you get a very accurate reading, whereas sometimes if you use some of the older sort of universal indicator tests, the coloured cards might fade a little bit, or you might get a slightly different reading holding it up to the light to see what colour it is. What we do in a soil testing digital kit, we store the probe in a solution so that the probe doesn't dry out. That's very important. Obviously we need a pair of scales, and I've got my soil sample here. Sieve it through a 2mm sieve. So I'm just going to I'm going to zero it so that my tare is not added to the weight. And what I'm doing is I'm just going to put my soil in there, and I've got just about 18.8 grams as it happens. And what we do now is we add distilled or deionized water to that at the same ratio. So if it's 18 grams, we use 18 milliliters, and I can measure that in the tube here. Okay, and I've just got to add the same amount in this case. Some testing kits have different ratios. So what I'm going to do, I'm going to pop that into this little beaker. Okay, pop it into the beaker so you can see I've put my soil sample into the beaker. I'm now going to measure my 18 milliliters using distilled water. Come up to 15, and there we go, that's 18, just a fraction over. Pop that in. Okay, and then what we do is we whisk that up. Give it a good stir, and then what's going to happen, you're going to leave that for about 15 minutes to allow the hydrogen ions that are in the soil into the water. So it's all mixed up, it's all in a solution now. The soil is just dissolved into the water. So that's our solution. We've got that. And now we can do away with the scales. We don't need that. And the next thing we're going to do now, while we're waiting our 15 minutes, is we're going to do some work on the pH meter, because what we've got to do is to calibrate this so that it's accurate. So I'm going to just undo the top, and that has been in a solution, and that is a slightly low pH, so you can't put this straight into your buffer solutions. So what I'm going to do, I've got some distilled water in here. I'm going to rinse the probe around, clean it, and make sure there's no residue around it. Then what I've got here is a pH buffer solution, pH 4. And what we do now is we calibrate the digital pH meter, the soil pH meter. We're going to calibrate it. So when I put it into this solution, it should read pH 4. We're then going to put the probe into distilled water to clean it. We're then going to put the probe into a pH of 7 to check that that's calibrated right. Once the calibration is correct, we can then proceed with the soil test. So I'm starting off with my pH 4. Okay, these are new, so they've got a seal on. Take the seal off. I can now switch on the power, so you can see at the moment it's a pH, well, it's varied of course. So what I'm going to do, I'm just going to pop that into the solution, buffer solution 4. Okay, so that's buffer solution 4, pop it in, and we're getting a reading of 4.04. Let me just show you that. So we just got it into the buffer solution, and you can see 4.3, 4.1, it's just a fraction over, it's hardly anything. In fact, it's settled there, pH 4, so that's pretty much bang on. If it wasn't bang on, then what I would do, I'm just going to put the top on that in case that falls over. Put that into the solution. Okay, put that there. And then what I would do is on the side here, I remove the side off here. And if you look on the side there, you can see that you've got pH 4, pH 7, and there's a little screwdriver which you adjust that screw with this in the solution of pH 4 and until that reading is 4. Okay, so it's very important that you get this calibrated right. So literally I would have to have the top off of that. So I'd need to have the top off that, put that into there. Okay, I'd have to get someone to hold it, put the screwdriver in there and twist the screw until that pH is reading pH 4. Okay, you have to wait for it to settle, okay, and so this one, I've just tried it before and we were on 4, so we were okay. Once you've done that, you can then take it out of there, put it in the distilled water, okay, put the top on so you don't knock it over. Once I've done that, it's in the distilled water, so it's all cleaned. I'm now going to do it in the pH of 7. Okay, so we've got our solution. I'm now going to put it in the pH 7 solution. Okay, so that was on top, pH 7. So into pH 7 solution. I've been in distilled water, so remember, always go through distilled water to clean the probe. Put it into the solution. And what you're looking for now, of course, is that that should be pH 7. And you can see it's settling down at just a fraction over maybe. 7.05, 7.2, it's gone to 699, 7. Okay, so you just wait for it to settle out. And this, just make sure the probe's right in there. So the probe's in and it's 695, so I think this needs a little twist. So what I'm going to do, I'm just going to adjust that a little bit, just a fraction with a screwdriver. So literally you've got to put it in there and twist. See the little things there, you've got to twist it with a screwdriver and then put it back in the solution, or if better still, obviously keep it in the solution and until you get your reading of 7. So that's 6.5, so I'm going to go back the other way with this. Again, it's better if you've got someone holding it, of course. It's important when you do this to turn it over on its side, just so that you can see that's hitting 7 now, so that is calibrated correctly. Now that I've done that, I can wash the kit, again put the top on the pH 7. Okay. Wash it out, make sure it's thoroughly washed, and then of course, now that 15 minutes have gone by, you can give that another quick stir. And let's take the reading. So now we pop the probe in, and the probe is telling me quite clearly on here, with that in, that we've got a pH of 6.05. Okay, so what that would mean is the soil is slightly acidic. So a pH of 6.5 to 7 is fairly neutral as far as plants are concerned, but anything less than that is acidic. That could mean there's a lack of lime, That could mean that a slight reduction in elements like magnesium, and also it's going to affect what plants you can grow. So you would recommend growing things like rhododendron, pyrus, some of the collunas, debusia, things like that, which like an ericaceous soil. They're what we call calcifuges. They hate lime, whereas calcicoles like lime. So if it had been a high pH, so above 7, then that would favour lime-loving plants. Obviously good for growing things like brassicas, things like Daphne mesoreum, forsythia would be good, lavender would be good, and even things like juniper and yew and beech and ash would tend to dominate on that kind of soil. So what you would do is, if it was a low pH, you might recommend adding calcium carbonate lime to increase the pH. You'd have to check that on a table to see how much you add for that particular soil. If the pH was high, then you wanted to lower it, you would add chips of sulfur or flowers of sulfur to try and reduce it, or just grow the plants that like those conditions. So that is basically doing a test using a digital soil pH tester, and that's something that we need to do for the new RHS practical exam at level 2. And then when you come to design the garden, you know exactly what you need. But don't walk away from it now, because you'll probably forget the reading. So we need to make sure we've recorded what the reading is and the exact pH, and then obviously when you interview the client to find out what they want, you can pick the plants to suit. Okay. So a bit of maintenance now. We need to wash the probe, and very importantly, we need to store the probe. I can switch it off now, it's been washed. I need to store the probe in a solution, otherwise the probe will dry out and it will be no good at all. So it's very important you store it back in solution, and then we can put all the bits and pieces away. I can put the side on the, because I've calibrated this now, hopefully I won't need to do it every time, but I'll certainly need to check it. And now I've put that cover on, got my screwdriver, very little screwdriver, so you want to make sure you keep that, pop that back in the kit, and then we're good to go on the next test. So I hope you found that useful, and we'll have a look at conductivity next.